Okay, so for the first picture it's about the fixed end, and then it's a low damping and high tension. So the damping we set it to 0%. So at 0% there is no energy loss. So the wave maintains its high amplitude all the way to the end. And then for the tension is 80%. High tension makes the string tighter. This allows the wave to travel faster and look more stretched out. For the result is a strong consistent wave that reaches the clamp with its full energy. Okay, for this picture, I set it the damping to the medium, so it 30%. The damping is turned up, the string resists the movement. As the wave travels further away from the source, it loses energy. The wave die out or gets smaller as it moves to the right. For the tension is I set to 60%. The string is looser than in the first picture. This causes the wave to travel slightly slower and the humps wavelengths to appear closer together. So the result for this picture is a wave that starts strong but fades away before it gets to the clamp. Okay, for this picture, I will set it to the high damping and low tension. For high damping, I set it to 80%. So it will represent resistive forces like friction or air resistance. So the damping is set so high, 80%, the energy is drained so quickly that the wave disappears before it can even reach the middle of the string. For the low tension, 40%, tension affects how fast the wave moves. Low tension makes the string loose, causes the wave to travel much slower, makes the wave look more compressed, shorter distance between peaks.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nuraina Akila binti Burhanuddin, and today I will explain to you for my lab 5, which is topic wave for part 2 for loose end. Loose end for part 1, we put the damping is high and the tension is low, and we can see the simulation like this. The wave pulse moves slowly along the string. When it reaches the loose end, it is reflected upright. The reflected pulse has a small amplitude and fades quickly. And when low tension happens, the wave speed is low, so the pulse travels slowly. And when high damping happens, the large energy loss, so the wave dies out fast. Because the end is loose, it is free to move, so no inversion occurs. The wave pulse travels slowly along the string due to the low tension, and because the damping is high, the reflected wave has small amplitude and lost energy quickly. Next, if we change the damping is low and the tension is high, we see the simulation. The wave pulse travels faster and the reflected pulse is clear and strong. Reflection is upright, same direction as the incoming pulse. When the high tension happens, the wave speed increases and the low damping, very little energy loss. And the loose end move freely, so the wave reflect without phase change. The low damping allows the wave to retain most of its energy, and despite ideal loose end reflection where the boundary is free to move. And lastly, if we change the damping in a medium, we put at 43 and the tension is 43 also. We see the simulation. The wave travels at a moderate speed due to the medium tension, and the reflected wave remains upright, indicating no phase change at the loose end. Medium damping causes a partial energy loss, resulting in a reduced reflected amplitude. And this is shows that reflection orientation depends on boundary condition rather than the damping. So to conclude for the loose end part, the result shows upright reflection because the free boundary allow, maximum displacement and preventing phase inversions regardless of damping or detention.
Okay, for this picture, I set it to low damping and high tension. So for the low damping, I set it to 0%. Since it's set to 0, the wave does not lose energy as it travels. It maintains the amplitude all the way across the screen. So for the high tension, I set it to 80%. High tension means the string is pulled tight. This allows the wave to travel faster and look more stable. For the result, a perfect repeating sine wave that continues out the window without fading away. Okay, for this picture, I set it to high damping, which is 100%. Because damping is at maximum, there is a lot of resistance. Energy is absorbed very quickly, causing the wave to shrink and disappear almost immediately after it is created. So for the low tension, I set it to 20%. The string is loose. This makes the wave travel much slower and appear floppy. So for the result is the wave dies out very quickly, turning into a flat line before it even gets halfway across the screen.
If you put the damping in the medium, 54, and the tension is also 54, you can see the simulation. It's happened like this. The wave pulse continues traveling forward, and there is no reflected pulse coming back, and the wave gradually fades along the string. This is happened because no end represents an infinitely long string, and there is no boundary to cause reflection. Energy continues moving forward, and it's slowly lost due to the damping. And this is a simulation that demonstrates the pure traveling wave that's confirmed the reflection is required for standing wave. And the wave pulse continues to propagate forward along the string without reflection. And the wave gradually decreases in amplitude due to the damping. And to conclude the no end part, the reflection confirms that without an endpoint, wave energy is transmitted forward, and this is paid only due to the damping.